What do you mean by arrays in C? Why do we need arrays? What are the rules to declare them? And lastly, what are the different types of arrays? Let's try to understand these topics in our today's video. Hello everyone, welcome to our channel Link Frequency and I'm Aishwarya Pattar. This video is part of our course that is C Programming for Absolute Beginners 2022. So without any further delay, let's get started. Array is a derived data type in C which is constructed from a fundamental data type. An array is a collection of similar type of data elements in a single entity which are stored in a contiguous memory locations, and these elements can be accessed using the indices of an array. Each data item of an array is known as elements. Each element of an array is having a different and unique index number which is known as subscript. The elements of an array can be accessed using the same array name by specifying the particular index number. Moving on to our second question, that is, why do we need arrays? Let's consider a scenario where we have to calculate the average of 100 integer numbers which are given as input from the user. In C, there are two options to do it. The first option is define 100 variables with int data type and then perform 100 scanf operations. Later, calculate the average of them. Or there is a second option, that is, have a one single integer array to store all the values. Loop the array to store all the entered values and then perform the average calculation. Looking at both the options, which one would you choose? Obviously the second one, right? Since it is easier to save the same data type in one single variable and then later access it through the array index. An array in C is of following types, that is, one-dimensional array, two-dimensional array and multi-dimensional array. Today, in this particular video, we are going to more focus on one-dimensional array. One-dimensional array is also known as 1D array. It is the most simplest form of array found in C programming. This type of array consists of elements of same type and these elements can be accessed through their indices. The first index is known as lower bound and the last index is known as upper bound. Now let's move ahead to understand what are the rules to declare a one-dimensional array. An array variable must be declared before it is used in the program. The declaration must have a data type like int, float, char, etc., a variable name and a subscript. A subscript represents the size of an array. If the size is given as 5 or declared as 5, then the user or a programmer can have 5 elements to store. In an array, the indexing starts from 0 and ends at size -1. For example, if an array variable is declared as array of 10, then it ranges from 0 to 9. Each element of an array is stored in contiguous memory locations, which can be accessed using the array index. Array in C can be either initialized during compile time or runtime. Let us understand them together. The first one is compile time initialization. It is also known as static initialization. In this, the array elements are initialized when we declare the array. During compile time initialization, the values which are not initialized take up a default value, that is 0. Moving on to runtime initialization. Runtime initialization means the array is initialized at the runtime. This means the initialization of the array elements happen after the compilation of the program. During the runtime initialization, the values which are not initialized take up a garbage value. There are few more points to discuss about the array. Let's move on to our screen to know more about it. As indicated earlier, we are going to discuss about one-dimensional array. So, there are few points inside one-dimensional array. The first point is regarding the syntax of the one-dimensional array. So here, the syntax include data type, variable name and size. You can see an example here, that is int array data of 10. So this is how the syntax of one-dimensional array looks like. Then the second point is regarding the array initialization. Since we discussed about initialization, that is runtime and compile time, the one represented here is the compile time initialization. So whenever we declare the array variable, we also give the array elements in it. So these array elements are included in a curly bracket. So we have int array num of 5 in the bracket, from 0 to 4 the values are ranging. So this is how the array initialization happens. Then let's move on to our third point, that is the representation. Since we discussed that the array values are stored in contiguous memory locations, that is in a continuous way. So how they are stored is represented here. So here you can see there is array of 0, array of 1, array of 2, array of 3 and array of 4. And the array indices starts from 0 and it ends at 4. As we had already seen during the rule, that is indexing starts from 0 and ends at size minus 1. So here our size is 5. So 5 minus 1, that is equivalent to 4. Here 0 is known as lower bound and the 4 is known as upper bound. To sum it up and explain, here you can see an array of 0. In the indice number 0, this particular value 0 will be stored. And in indice number 1, the value 1 will be stored. And in this 2 and 3 and lastly the value 4 is stored. So these storing of the values happens continuously. Moving on to our fourth point, that is how can we access the array? That is through a simple method, that is we have here array of num and followed by the index. So whichever location you want to access, you have to just give the index number. And moving on to our last point, that is how can we know how much memory is consumed for this one-dimensional array? There is one simple formula we can know the size, that is the total size in bytes for one-dimensional array. The formula is size of data type into size of array. To explain it in more detail, let us take an example. The example is already mentioned here. Here you can see int array of 5. So int is the data type, so it has 4 and the array size is 5. So overall we have 4 into 5, that is 20 bytes. So 20 bytes of memory is consumed to store this int array of 5. So these were the few points related to one-dimensional array. Now let's move on to understand in depth with the help of an example. Now let us understand more about 1D array with the help of an example for both runtime initialization and compile time initialization. Let's move ahead to our screen. Our first example shows about compile time initialization. We will follow the standard as per our documentation. Here I have used int array of data 5 and all the array elements are initialized as per the syntax of compile time initialization. This is done here. And to access the elements of the array, we have to use a proper indexing number. So to do that, I am using a for loop to traverse into all the possible values, and all the values of that array will be indexed through this variable, and I is used for the looping of the array. Now let me try to run this code so that you can see the example more clearly. As per the syntax, the initialization of an array is done. So all the values you can see in the result. In the index 0, value 15 is stored. In the index 1, 25 is stored. In 2, 35 is stored. 3, 45 is stored. And lastly in 4, 55 is stored. This is how the array happens to store in a very contiguous memory locations. What if I don't give one of the element here? One of them is not mentioned. Let's see what happens. Let me rerun this code. So if any one of them is not initialized, then by default 0 will be stored. So this is all about the compile time initialization. Now let's move ahead to our next type of example, that is runtime initialization. Here I have used int array data 5 and I'm going to take the input from the user. That is the reason I have used printf statement. And the for loop is used to take the runtime initialization or to store the values that is taken from the input. Lastly, I'm going to print the values whatever are stored in the array. Let me run this code so that you can see the example very clearly. I'll give the input as 10, 15, 20, 25 and lastly 30. So the results you can see here. In array data of 0, we have value 10. In array data of 1, 15 is stored. In array data of 2, 20 is stored. In array data of 3, 25 is stored. And lastly, in array data of 4, 30 is stored. So this is how the array stores the values in a contiguous memory locations when the runtime initialization is considered. Overall, in our today's video, we discussed more about one-dimensional array with an example. For any queries, you can surely comment down in the comment section and your queries will be answered as soon as possible. Thank you so much for watching our video. I hope you could enjoy the video content. Consider subscribing to our channel Link Frequency, and also don't forget to share our videos across all your connections. Until we meet on our next video, happy learning. Tune yourself to make a difference.